Okay, so how many of you have referred to the notes that I have given you on in the previous class? You know, I had shared the notes, right? So how many of you have referred to it? You can raise your hand so that it becomes easy for me to understand uh, as to how many of you have done it. Yes, Sayan, I will actually share the marks. Okay. Let me just confirm it with HOD once. Okay. And then we will look at, the quiz marks. It's ready with me right now. Okay. And I will share that. Shouldn't be an issue once I get a confirmation from the HOD. Okay. So how many of you have referred to the notes that I have given you on? You can raise your hand. You have an option to raise your hand. So what was the previous topic that we all discussed? Okay, Mitesh, Sayan, thank you for the response. What was the previous topic that we all looked into? Key maps, good. So what's a key map? Someone can unmute and respond. Yes, go on, go on. Someone is trying to respond, please go on.
The combination of truth table and Venn diagrams.
Okay, fine. So it's a combination of truth table, fine. And what's the purpose, Rohit? Like, why do we use it?
It's used for minimizing functions.
Mm-hmm. Okay. And what's the advantage of getting a function minimized? Is there an advantage, or are we just doing it just for the sake of doing it?
It's easier to analyze it then.
Exactly. Fine. Anybody else wants to add? Thank you, Rohit. Anybody else wants to add to what Rohit has told us?
It is pictorial method to minimize the Boolean expression.
Are you able to see the screen? One of you can respond, please. Okay, fine. Thank you. Go ahead. So we have seen all this human. Then we learned what is and what are the standard things, okay, that needs to be done to get things, the equations into a simplest form, right? What's the advantage? As some of your friends mentioned, okay, the advantage is that you can actually get a simplified version, right? A simplified version, and with that, it becomes simpler for us to implement a circuit. Okay, now can someone tell me what is on the screen? What can you see on the screen? So now today we are trying out different thing. So without your input, it's going to be difficult for me. So,
Sir, it's blank, sir.
go ahead. It's blank.
It's blank.
Huh? It's blank. Okay. Go ahead. Push.
Screen, yes, you're sharing, but there's nothing on it.
Okay. Fine. So that should be the network issue. Just give me some time, please. I'll try and look into what can be done best. Just trying to send the file across.
You can see, sir.
Now you can see. Okay. Thank you for confirming that. just confirm? Is it express Boolean function f is equal to xy plus x bar
Yes, sir.
x?
Yes, sir.
You can see.
Sir,
Okay.
example, sir.
Okay. Fine, fine.
Example, sir.
I'm actually on the next screen. Then okay. Now I think it's fine, right? You can see K-maps. Is it?
Yes, sir.
Okay. Now, now the topic of discussion for us is going to be K-maps. Okay. And we are going to use 3, 4, and 5 variables. Okay. Now, the thing that you have to understand here is that, you know, you will be using, okay. So you will be using these three things. I think I'm visible. Yes. Whatever marking that I'm doing, are you guys able to see? Please respond. Yes. Okay, fine. Thank you so much. Right. So, yeah. So these three things are the properties of a truth table. Okay. The truth table representation of a function is unique, expressed algebraically, and appears in many different forms. Now, not only this, we have to look into something else, which actually helps us in understanding uh, what is best for us in getting things rectified. Okay, just give me a moment. At the end of the class, what I'll be doing is I'll be sharing a video with you all. Okay, wherein you will be able to understand, as to how these K-maps are drawn. The only challenge that I'm facing right now is with the network. Okay, so just give me some time so that I will try and rectify this. It's a challenge for all of us, and we have to go through this challenge. Just one moment, please. So we have seen this key map. It's also called Welch or Karnoff map. Okay, so let's get started. with this three variable maps. Okay. Before we get started, okay, I want you all to understand as to what is a K-map and what is the structure that is used for a K-map. Okay, so if you can see here, okay, if you can see here, you have M0, M1, M2, M3, M4, 5, 6, 7. Okay, so yeah, so let's take okay. Now, if you see here, normally what is our chord? We start with 0, okay, and then now we go with 1, okay, 1, then 2, right, 2, and then 3, right. So this is our thought of a K-map. But here, what is happening? What is happening? We are first seeing 0, okay, and then we are seeing 1. Then 2 is actually coming here, and then 3 is here, right? So the reason why it is happening is you see this lower section, okay, the lower section which is here. First, it starts off with 0, 0. As I told you, there should be only one bit change, okay. Now, what is that one bit change that we are talking about is, now let us compare this 0, 0 and 0, 1. Now, if I compare this 0, 0 and 0, 1, how many bit changes are there? Can someone tell me how many bit changes are there? I want you all to respond. Yes, one bit. Good. Now, how is it one bit? Because now 0 is already here. Okay, 0 is already here. And we have another 0 here. So, which means both the bits are same. Now, there is only one bit change which is happening here from 0 and 1, right? So these two bits are only getting changed, which is 0 and 1. Now let us compare, okay, let us compare the previous one, okay. Let me just clear it out so that it becomes easy for you to, understand. Okay, now let us compare this section and this section, okay, the same analogy, okay. Now here, what are the similarities? Similarities is 1 and 1, right? But the first bit here, 0 and 1 is different, right? So this is my motive, okay? So normally what we do, we have 0, 0, 0, 1, okay, 1, 0, and then 1, 1. Now, this is our normal truth table. Now, if I go ahead with these two options, yes, there is going to be one bit difference. Okay. How is the one bit difference? This one is my difference, right? Next, if I compare my next combination, which is 0, 1 and 1, 0, okay, what is going to happen? What is going to happen? Can someone respond? What is going to happen? There is going to be two bit changes, okay? Here I have 0, 1 getting changed, and I have 1, 0 also getting changed. Okay, I do not want two bit changes here. I just want one bit. So instead, what I will do is I will just shift them across. 1, 1 is brought here, and 1, 0 is brought here. So that, okay, what is going to happen? See my truth table here. So that what is going to happen? I will have just one bit difference. So 0, okay, and 1. There is going to be just one bit difference. Fine. Now compare the last one, okay, with 1, 1, okay, with 1, 1 and 1, 0. 1, 1 and 1 0. Fine. So here, if you can see, this 1 1 is the same, right? There is no difference. The only change occurs in the last bit, which is nothing but your 1 0. Right. So that is the reason that we are actually taking all these, right? We are trying to, just a moment, please. Okay. So we are trying to interchange from here, okay? 1 0 should have been here, but then, it has changed. Okay. So I hope you have understood as to how, we are actually trying to have a goal of 1 bit change. Okay. So this table that you see at the bottom, okay, you should be able to understand. Okay. Uh, okay. So here you go. So this table you should be able to understand. Now, just like, how we have our truth table, X, Y, Z, okay, then I have from 0 0 0, okay, to, okay, it's going to take me to, okay, 1 1 1, right? So this is going to be my max from 0 0 0 till 1 1 1, right? So the same way, what I'm going to do is I'm going to have the truth table here, okay? So the first one, I split them into two. So X I'll be taking in one side, okay? So that X is here, and then YZ is taken here, okay? So if I have just X here, it is 0 and 1. YZ is 2 bits, okay? So since it's 2 bits, I will have, as you all know, 4 combinations, which is 0 0 0 1. Now again here, not 1 0, but it's going to be 1 1 and then 1 0. So accordingly, if it is a 0, okay, 0 0 0. So all the three terms becomes bar, X bar, Y bar, Z bar, okay? And here, since I have 0 0 1, okay, 0 0 1. So X bar becomes 0, Y bar is also 0, Z is high, okay? Is it clear? Can someone respond? Are you understanding as to how we are getting X bar, Y bar, Z, and X bar, Y bar, Z bar, Y bar, Z bar? Yes, you could use the chat box here as to how we are getting this X bar, Y bar, and Z. You can use the chat box. Okay, fine.
Yes, sir.
Okay, Rohit, thank you for responding. Similarly, okay, let this one, okay, the last one, 1 1 0. Okay, so since we have 1 1 0, here what I'm going to do, X is going to be high, Y is also going to be high, but Z, since I have 0 there, okay, since I have 0, what is going to happen? It's going to be my Z bar. So this is how we are going to use our K-map. Okay, so I hope you all have understood as to how this is happening, right? Okay, so we will just move on to the next section, okay, and we will try and understand as to how this is actually put up, just like as in your table. Okay, so we have something here called simplify the Boolean function. Okay, a function is given, and I am supposed to actually simplify it. So how will I simplify it? Okay, so let us just check. That is just for an example. Okay, just for an example as to how we can actually take it. Okay, M5 and M7. Okay, just an example. Now we will see here and try and understand as to how we get it. Okay, I want you to just understand what is inside the table here, okay? And now I want you to understand this particular problem that we are going to see, okay? This problem, fine. So we have a function x bar y z plus x bar y z bar plus x y bar z bar plus x y bar z, okay? This is our equation. So what we are going to do, the same thing we are going to represent here, x, y, okay, I have my x, I have my yz, okay, 0, 1, 0, 0, okay, then 0, 1, 1, 1, 1, 0, okay, this is going to make combination, always, guys, keep in mind, always, this is going to be my combination. Now here, okay, since I have used, okay, let me just clear out so that it's going to be easy for you to understand. Okay, now since I have used here x bar, which means 0, okay, x bar, oh, okay, so x bar means I'm going to take it as 0, okay, then y is going to be high and z is also going to be high, right? So which means it is 0, 1, 1, okay, so just check where is 0, 1, 1. I have it here, 0 is here, 1, 1 is here, so that section becomes high, okay. So similarly, it has 0, 1, 1. So I can write this as 0, 1, 1. So where am I getting this? Look into your screen, okay? So 0 is here and then 1, 1 is here. So I am going to put 1 exactly here, okay? So this is my square, which is, mapping to that value. This is my square. Are you able to follow? Yes? Someone please respond. Able to follow
Yes,
as to,
sir.
yes, okay, similarly, okay, since we have 0, 1, 0, okay, so 0, 1, 0, so this is going to be filled, okay, accordingly, this square and this square. So I am going to put them as 1, 1, 1, 1 wherever the function is given to us. So once I get this function, my idea is to group them, okay, so the next idea is to group them, okay. So how do I group them? 1 and 1 is next to each other, okay. So if I fold this okay towards this line, if I fold it, okay, then what is going to happen towards this line and towards this line, what is going to happen? These 1 and 1 are going to overlap each other, okay. So since it's going to overlap each other, I am going to group them together, okay. I am going to group them together. Now let us take this 1, 1 and 1, 0, okay. Now these terms I am taking here just for the sake of simplicity. Now since I have uh, since I have my functions here 1, 1 and 1, 0, okay, so we will try and understand as to what is going to happen. So 1, 0, if it is opposite bits, they get cancelled, okay. Now remember, this is y and this is z, okay, y and z. So since it is 1 and 0 here, the last bit, okay, this last bit here, 1 and 0 here, they get cancelled out. So what is remaining here? Y is remaining, y, that is high value. And across, okay, across this line, what do I have? I have x. X is nothing but 0. So it is going to be my x bar y. Are we getting this here? Yes. Are we getting that there? Right? Similarly, the same thing applies here also. Okay. Now here I have 0, 0 and I have 0, 1. Okay. So what is going to happen? 0, 1 is going to get cancelled and this is going to be my X bar, right? So X bar is remaining. Now towards this line, I just have, sorry, this is going to be my Y bar, Y, right? This is Y and Z. So which means it is not X, it is Y, Y bar. And this is going to be my X, right? So X, Y bar plus X bar, Y. So that's going to be my final equation. Okay. So using all of this, I combine both of these terms, okay, and I get this final equation. So I hope you are clear as to how we have minimized a four-term equation. One, okay, 1, 2, 3, 4, a four-term equation into actually a two-term equation. Is it clear, guys? Yes? Can I proceed? Can I proceed? Okay, fine. You want me to explain again? Okay, we'll go ahead. I will just clear the responses, the annotations, so you'll be able to understand. Fine. So an equation is given to us, okay, which is nothing but a four equation, okay. So using this K map, okay, we are actually going to change it and okay, just a moment, please. Okay, so we have these four equations, and accordingly we are going to put, we are going to term them as one, one, okay, one and one. So if these ones are together, okay, now let us say, for example, okay, let me draw. Okay, so how many do we have? Okay, we in fact have more. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we need 8 squares. Okay. So let us say I have a 1 here and I have a 1 here. Can I group them? Someone please respond. Can I group them? Yes, exactly. We cannot group them because they are not together. Instead of having it here, if I have in this spot, if I have in this spot, then it is going to be easy for me. So which means I need to have the ones next to each other. Okay, so once I have this, I will group them. Okay, and I will see what is across my what are my parameters here, x, y and z. If it is a 0, then I'm going to take x bar. Okay, if it is a 0, and if it is a 1, then I'm going to take x. Okay, 0, 1. So this is going to be my x bar. Okay, x bar, and this is going to be my um, x, sorry, x, because it's height. Okay, so accordingly we get this equation, we get the final equation. Okay, so what's the final equation? I have x, y bar, and then x bar, y. So I get my final equation. Is it clear, students? Is it clear? Can we proceed to the next section? Okay, fine. Thank you. Now all of you take this as an example. Okay, take this as an example, and we will see. Okay, we will just solve this problem for today. Okay, and we will see as to how we are going to do it. Okay, can you all please take down in your notebook and practice. Now remember, just by listening it's not going to happen. You guys have to practice, you guys have to use a pen and a paper, okay? Try putting the K-map and, you will be able to understand properly. So all of you can look at this. One more easy way that I'm going to, actually tell you all is, that whenever you put table, uh, okay, so let me just put a table across here. Okay. So I'm going to value my cells now. Okay, so this is going to be 0, 1, 2, 3, okay, 4, 5, 6, 7. I am valuing my cells. Now, what is this? What is this 0, 1, 2, 1, 2, 3, 4, 5, 6, 7? This is nothing but, okay. Now, if you go back, okay, if you can go back a little, and yeah, and if you can see this, okay. So here, what is happening, since I have 0, okay, 0, 0, 0, okay, I have here, okay, 0, 0, 0, so it's going to be 0, it's going to be 0, it's 1, 0, 1, 1, so it is 3, 0, 1, 0, so it is 2, okay. So this is how, we are actually doing it. Okay, so if you do that in that fashion, it becomes easy for you. Okay, so we will just quickly see this problem. Okay, and we will try and understand as to how to solve this. Okay, so I want your attention. Okay, anyway, I will be sending the recording of this. Okay, and if you guys have doubt, so you can always look into it. Okay, and we have many ways to reach out. Fine. So we have an equation now. Okay, which is nothing but our x bar, okay, x bar yz plus xy bar z bar plus xyz plus xyz bar, right? So this is our equation. Now here what we are going to do is we are going to put ones wherever they are, okay? So here I'm going to get this combination, okay? So which means I'm getting a 1 here, okay, and then a 1 here, 1, 1. Now this 1 is single, okay, so I cannot group it in any way, but there are two ways of grouping it, okay. The first way is that, okay, what I'm going to do is I'm going to group these two ones, okay. So once I group these two ones, this one also I can group it in this fraction, fine. And since I have a single one here, okay, so it doesn't have any pair, I will just leave as it is. Instead, okay, the second method of doing it is that, okay, what I will do is I will just group them here, okay, and then since I have a 1 and a 1 here, okay, if I fold this, okay, let me just use another color so that it will be easy for you to understand. If I fold this across, okay, in this fashion, if I fold this, these two ones will actually touch each other, okay, these two ones will touch each other, which means I am looking at convergence, which means I am looking at something which sits on top of the other, okay. This box will actually sit on top of this box if I fold it across this fashion. If I fold this 8 squared structure, if I fold it in this fashion, okay, it is going to collide. So using this, what's going to happen now? Clearly we can see that since I have a 0 and a 1 here, this gets cancelled out. It is 1 1 here, which means yz. So yz is here, I'm getting my yz here, okay. Similarly, I have a 1 here and I have a 1 here, okay. So I have 0 1 getting cancelled, and I have 0 and 0. So 0 and 0 is what? That is for z bar. Z bar is done. And that is across what? That is across 1, which is x. So this x comes here. So this is going to be my final equation. I think you're clear with this, students? Are you clear with this problem? Yes, please use the chat box or you can unmute and respond. So we are looking at grouping ones. Okay, the most important thing here in K-map is grouping ones. Once I have grouped ones, it becomes easy for me to reduce the equation in such a way that we can start implementing. Now see the difference between this equation and this equation, right? We have 1, 2, 3, 4. We have about 4 terms, but it is just reduced to 2 terms. That to what? Only just 2 variables, right? YZ and XZ bar. Okay, so I think we will stop here, and we will maybe continue in the next class as to how we will go about with 3 variables and 4 variables. Right now, we have started off with 3 variables, which is X, Y, and Z. Okay, and then we will see as to how we can go ahead with the other variables. Guys, are you clear till this point that we have discussed so far? Okay, Sayan, thank you so much. Okay, and I'll be sharing in the link shortly. Okay, and you can fill in the same. Okay. So the only thing